Eigenspace. Why are eigenspaces important for automatic control? And in a certain sense, we got from the example as before that this one is an eigenspace and this one is another eigenspace, true? Associated to two different eigenvalues. We are together on here, true? Perfect. Now, why is this stuff important for automatic control? So if I start here as my x, will I end up here as my y? No, I will end up aligned here, true? Perfect. If I start here, how will my x dot look like? If this is my x at time t, my x dot at time t is going to be looking like what? If I've got these x, I get these y, true? That means that if I consider the trajectories, I need to take the y and put it on top of the x to get the trajectory, true? And if I follow this trajectory here that is aligned on this space, do you think that the trajectory will go out of the space? No, it stays on the space, true? True? Very interesting. If x0 belongs to this stuff here, we say that this writing can be simplified into this writing, true? That means that my x of t vectorial is going to be what? E3t x0 vector. True? See? Whenever I start on an eigenspace as an initial condition for my free evolution, I'm talking about free evolution, true? I'm also always talking about free evolution. You see that I'm not talking about forced response. Are we together? Perfect. Whenever I'm on a subspace that is an eigenspace, my whole map that is n-dimensional potentially becomes the stuff that we already saw. Are we together on this, people? 1, 2, 3. So, let's see if we are together on this. For this, we have an eigenvalue of 1. I start from x0 equals to minus 1, 1. After one time constant, what will be my x at one time constant? Discuss. Try to find the solution. Try to get the solution. Let's decompose. Where do we start? Where are we starting? Where are we starting, people? We are starting here, true? Are we together that we are starting here? Perfect. If we are starting there, do we have x dot equals to ax, or do we have something simpler? Simpler. What do we have? X dot is equal to x. True? Perfect. How is the evolution? xt equals to et x0. True? Together? Perfect. Time constant associated to this one. We saw logical Volterra. This is expansion. It's 1 over this value here. That is 1. It's 1. After one time constant, it means that I'm at x of 1. That is e x0. That is going to be this one. How much are we together, people? 1, 2, 3. Watch out. The interpretation is that whenever we substitute a with a number, eventually it's like I start in some way, and then I will have a stretching factor. True? Okay. Perfect. Then at this point, this is now I'm pretty sure that you are going to see the important part here. So if I start here, after t equals 0.7 seconds, let's pretend, I'm going to be here. Let's pretend, I'm pretending, okay? And if I start here, after 0.7 seconds, I'm going to be here. I'm pretending, okay? Now, if I start here, after 0.75 seconds, where am I going to be? Discuss. Linearity, superposition of the effects. This is the sum of this cos plus this cos. Following me? This one is the sum of this cos and this cos. This cos creates this effect. This cos creates this effect. The effect of this is going to be the sum of the effects. Okay? Together? Now, how much are we together, people? 1, 2, 3. Perfect. If I consider this initial condition here, or better, let's restrict ourselves to this stuff here, to this subspace here. Okay, we are restricting our discussion to this subspace here. Ignore the second dimension. The origin, how is it? Asymptotically stable, marginally stable, not convergent. Not convergent, not marginally stable, neither. You do not know. 1, 2, 3, 4, 5. People, I would like to see what you are saying. Everybody says 4, because eventually, if I look at only this eigenspace, this is the ODE, true? If I look at only that subspace, the ODE is x dot is equal to 3x. Very much not anything. It means that somehow, if I start with a certain initial condition, I will escape, true? With a certain velocity. The time constant here is going to be 1/3, true? The time to not double, but get to e x0, e2, x0, e3, x0, time constant is 1/3. If I start here, will I escape? Yes. Will I escape faster than here, the same speed than here, slower than here? You do not know. Is the question clear? Here we have particles that you start here, you escape with a certain speed. Here you start here, you escape with a certain speed. True? Which one escapes faster? This one. True? Are we together on this, people? If I start here as my x0, the trajectory is going to be what? It's going to be the combination of this explosion. It's not an explosion, but this running away plus this running away. True? But this one is faster. True? At this point, starting from here, will my trajectory be like this one? this one. Let's make it, I enhance them. I make them closer by, it's the same, and I will make it thicker. Do I have something that is like this, 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 or this? 1, 2, 3, 4, 5, and 6 is, I do not know. Let me see. What would you say, people? The majority says the correct one, that is 4. Let's think about why. So it's something that, why is it not this one? This one, if I decompose this trajectory, it means that along here I've got something that explodes and something that converges. True? Do we see it? Because for every time I will be at a certain point, here, 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 and then I have to kind of consider those ones. Are we together? I'm drawing it in a way that probably is, that one cannot be. If it is something like this, it means that I have the same speed of convergence. True? Are we together? That going straight will kind of mean the same speed of convergence, of divergence, sorry. This one, if I sample in time, I will have this, true? And here we'll have this, true? Because it explodes slower. If you build up byte points, you will see that it's diverging in this direction, but it's going to be something that looks like this. Okay, are we together, people? Draw me a trajectory, assuming ignore A1 and A2. Assume that the spans are the same, and we have this situation here. Go, draw it. I start from here. If I start here, what do I do? If I have x dot is equal ax, that is also equal to 0x. This is 0, true? That means that if I start here, I stay there. If I start here, I stay there. If I start here, I stay there, true? What do I have as a trajectory starting from here is going to be this trajectory that stays plus this trajectory that explodes is going to be together. 1, 2, 3. Tell me how those two, for this matrix here, how those two eigenvalues have to be to have the origin to be asymptotically stable. I think you don't write stuff. Try to understand. Don't write stuff. It's everything is said. It's a recording. Focus here. If I have If I want trajectories to converge, it means that along here I need to converge, and along here I need to converge, true? I need to have both negative, strictly negative, true? Are we together, people? Tell me. They are very easy, but they are kind of. I'm trying to, by those ones, giving you words that you might use every use. Everybody says, I hope. Three. Invariant directions. In which sense invariant direction? I've got x that goes into lambda x. That means that the derivative is pointing in the same direction. It's a direction that is invariant. True? And in a certain sense, it's the modes of the system response, of the system's free response. This I didn't say too much. If I do this and I say this plus this, what am I saying? In a certain sense, I'm using the eigenspaces as ways of decomposing the trajectory. True? Let's remember whenever whenever we were having y free evolution equals to 3e minus 2t plus 7 cosine 10t. This one was the stuff that we were doing at the beginning, starting from the impulse response, based on the output. And we were doing kind of a modal decomposition of the output. In which sense? Those ones were the modes that are kind of vibrations proper of the impulse response. And we were referring as this equals to sum of Lego blocks in the output. Where are we going here? X is going to be sum of objects. True? And they are going to be atomic objects. We are going towards the X of t is equal to sum of modes. Modes that do not live in one dimensions, but live in n dimensions. You see? We have, in a certain sense, V0, V lambda equals to 3 times E 3t, and then we will have an initial condition, plus V lambda equals to 1 E t times initial condition. You see? This one is this trajectory, this one is this trajectory, true? And then depending whether I take this initial condition, 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 I am blending them. How are we? 1 to 3.